Molten salt storage has seen increasing deployment to store energy from concentrating solar power plants. Molten salts like sodium nitrate or potassium nitrate allow thermal energy to be stored efficiently at high temperatures of over 500 degrees Celsius. This allows solar energy to continue providing power overnight. Phase change materials, PCMs, are substances with high heat capacity that melt and solidify at certain temperatures. They are used in buildings and hot water tanks to store waste heat and reduce temperature fluctuations. Advanced PCMs using salts, fatty acids, and eutectic mixtures can store larger amounts of thermal energy. Kinetic energy storage. Flywheel energy storage systems use advanced carbon fiber composite rotors spinning up to 50,000 revolutions per minute inside vacuum chambers to convert and store electricity as rotational kinetic energy with up to 20% storage efficiency. Advanced flywheels with magnetic levitation and near-frictionless operation are able to store significantly more energy in smaller volumes than lead-acid batteries, with lifespan exceeding 200,000 cycles. Chemical energy storage. Hydrogen energy storage using fuel cells provides high energy density and only emits water vapor. Underground hydrogen storage caverns and cryo-compressed tanks can store hydrogen produced via electrolysis when renewable electricity supply exceeds demand. Sulfur flow batteries consisting of liquid sulfur and chromium electrolytes separated by ion exchange membranes are able to store grid-scale amounts of electrical energy. They offer high cyclability and storage durations of 8–12 hours at installation costs cheaper than lithium-ion batteries. Cryogenic energy storage liquefies air using renewable power during periods of excess generation. The liquid air can expand to gases later to turn turbines and generate electricity when required. It provides large-scale long-duration storage but consumes up to 25% more power than what gets stored.